Thank you, everyone, for coming. Um, the title is Science Writing in English and for Impact. Uh, what we mean by impact will be something we discuss today. And the first couple lectures will focus on the impact portion, and the later lectures will focus more and more on specific problems that some of you may encounter as English is not your first language. And as Zhang Wei very kindly said, 我教苗 and I really need to thank the encouragement, Gongmian, the encouragement I've gotten. My old friend Peng Peng Lao Shi, you see us here when we were young men. And really, Wu Fuyan Lao Shi, Peng Peng Lao Shi, and Zhao Liang Lao Shi, all of them had this vision for me to give a series of lectures about scientific writing for the audience here at IGG. And it would not be without their vision and encouragement that we would be coming together today. So, 非常恭喜. Another word about a quick word about translators. There's Weixin, Baidu, Bing, Google. These are amazing tools that all of you no doubt use. But a word of caution to be used, okay? Translators are tools, but they can't replace, they can't write for it. So obviously, as I would do if I were trying to write in Chinese, there's a temptation to write what you want in Chinese and then use a translator. But keep in mind, these professors we just talked about, Wu Fuyan, Peng Peng, Zhao Liang, your professors did not use translators to write their papers. They had dictionaries. So it's okay to treat a translator like a dictionary. Your professors had dictionaries, and now you have a very powerful dictionary. But the main point is that real improvements in writing in English will come from thinking in English. So I will teach you what I can, but I also want you to realize that a great way to learn about writing in English is learning from your professors who are dealing with the same problems that you are dealing with, that I have a harder time understanding. So, 向他们学习。好的。And the last phrase on this theme of Gongmian is kind of the yin and yang between the mutual encouragement between writing and science. Hopefully, by the end of the lecture series, you will agree with these 2 points. First is that better writing makes better science. It will improve the impact of your paper. Your work will be better understood. And if your work is better understood, your work can be more widely accepted. But the other side is that better science makes better writing. You know, science and nature papers are very nice to read. And the writing is often a test for how impactful your work is. If the work sounds important, maybe it is important. And the last point is a lesson that we were taught by Rebecca Neely from Nature Geoscience, who visited IGG CAS from Shanghai. And she said, instead of just saying that your observation, your result is the first, can you really say why it is an important advance to an important problem? So here's the plan for the lecture series over the next 5 weeks. Each lecture every Thursday from 3 o'clock to 4 o'clock will be 1 hour. And the 5 lectures will roughly follow this structure, this outline. There will be some overlap between the different themes. But today, number 1, we'll talk about philosophy of writing, very general ways to improve your writing. Next week, in the second week, we will talk about structure, specific ways to structure abstracts, structure papers to improve your writing. The third week, we will talk about strategy, big things for big journals, things like writing cover letters, things like understanding decision letters, the strategy of writing papers, anticipating reviewers' reactions before they occur. And four, very specific tricks. As a native English speaker, a fluent English speaker, pardon, I will try to give these little things that make a big difference. And, this is things like grammar, formatting. If you have little mistakes, spell check, little mistakes can add up and can make give a reviewer easy things to criticize. So little tricks that go a long way. And the most exciting thing for me about this lecture series will be week 5, where I'm hoping for Wenti some questions. Okay, so from the beginning, you can email me. Only a little time in the lectures 1 through 4 will be allotted for questions. Very little time. I will want time to think about, assimilate, collective responses to your questions. The questions can be about things you learned in lectures 1 through 4 or questions you already had. They can also be about points of disagreement. If you take a different approach that works for you, I'd love to know and maybe share it with others too. Okay, so feel free to email me at any point over the next 4 weeks. And in week 5, I will try to put together collective responses. And I just want to point out some encouragement. You're not alone. A lot of what I will discuss with you, I will discuss in Chinese for fluent English speakers. Writing is critical for scientific reporting, but it is rarely taught. It is only taught from mentors to students, one-to-one, which is where most of my advice that I will share has come from. So thanks a lot to my mentors. And let's face it, most scientists are bad writers. Most of us look like the scientist in the top picture, all excited about the microscope in the field. And then when it comes to writing the paper, we look like the scientist on the bottom picture, very not excited. So a main goal of this series of lectures is to hopefully make you more excited about the writing process. And Dubichi, the slides will have lots of English words. I will read the slides and as well as sometimes elaborate. But I have all these words because I want these PPTs to be a resource for you that you can go back to anytime in the future, go to exactly the slide that you found helpful. So hopefully you find that useful. And very important is take it or leave it, okay? This is my advice from my personal perspective. What works for me may not work for you. Everyone needs to find his or her own style, your own approach. So some advice may be helpful. Advice may not be helpful to you. You will benefit no matter what from thinking about it. So sometimes I will even give you 2 very different approaches. Maybe you prefer one way over the other. Maybe one way works for one paper and another way works for another paper. So take it or leave it and adapt the different ideas to different situations, different papers. Most importantly, just the same way you think critically about your science, you need to think critically about your science writing. So here's the big question. Why are we writing? What's the goal? There's really 2 goals, okay? First is writing for achieving. Your new ideas, your new methods, the new science you've developed. This is the goal. There's a question people ask, whose paper is it anyway? This refers to peer review. You really want your paper your way. Okay. An advisor of mine, Mark Brandon at Yale, told me there's nothing special about a paper unless it's special. So don't let reviewers destroy your work. We'll talk about this more later. So number one is making your achievement. But number two is equally important, writing for achieving as well as writing for publishing. It doesn't matter how good your science is if it isn't published. Your paper is only impactful if it is understood and well received. So putting these together in number three, you need to do both. You need to write for achievement and you need to write for publishing. Balance between your interests and the peer review process. You need, on one hand, you need to be proud of your paper. On the other hand, practically speaking, it does need to get published and it does need to be understood by someone other than you. Now, some very general philosophy about writing and what you have to offer as a writer comes from two people. So Rebecca Neely, who visited us from Nature Geoscience, she had this great phrase where she said, if you have no idea, you have no chance. You can spend all this time polishing the writing, having a fluent native speaker like me help you with the writing. But if you don't have a very large conceptual advance, you don't have a chance at publishing in a journal like Nature Geoscience. And how do you find that idea? Well, Ernest Hemingway, one of my father's favorite writers and a very famous American writer, Ernest Hemingway said, write what you know. Okay, what does that mean? It means you have to find what you have to say. Follow your heart in a sense. So don't focus so much on the tricks and the details of polishing your English. You can focus on that stuff later, which we'll talk about later, but it really needs to begin with finding what you have to say as a scientist. And writing is important because it's a major part of the whole process of science, okay? Do not underestimate how much of science is writing. Students learn a lot of things. Rarely do they learn writing. Your career depends on your ability to write. So I asked the question, what percentage do you think, what percentage of the whole process is writing? I would argue that it's a surprisingly large percentage, and most critically, it's the last critical step. The analogy I'm using here is climbing Mount Everest. If you want to get to that Nature Index level publication, the summit of Mount Everest, there's a lot of steps along the way. Reaching the base camp, okay, takes some effort to get to in the first place. Just to be able to do the field work, you have to know something about the science. And after the field work comes the lab work. This brings you up to Camp 1. Then you write your draft paper, work with your professor, and you finally get up to submission, which is Camp 2. And then the reviews come back. That's Camp 3. You have to do the revision, brings you up to Camp 4. And maybe you have another revision, Camp 5, the Hillary step. And finally, you arrive at the summit, which is publication. So if you look at this whole process, writing is everything above Camp 1. So it's at least 50% or close to 50% of the process. So do not underestimate its importance. Simply because it takes a lot of time and a lot of effort. It doesn't matter how good your lab work and your field work is if you can't get to the summit. So, what do we mean by impact when we say impact? And there's different ways to make an impact. There's different ways to get promoted in your career. Obviously, what most of us mean by impact are nature index journals. And this is impact in terms of visibility. Many people read those journals. Many scientists will know your work, even beyond geology, potentially. And then there's also ways of having an impact in terms of citations. There are high citation papers, some papers with thousands of citations. And then there's high citation careers, the H index, how many papers are cited how many times. And citations are an impact in terms of legacy. And then there's the third way to have impact uh, that is hard to make into a metric, but it is obviously real and helps you get awards, and that's respect for your colleagues. This is an impact in terms of credibility. And I wanted to give two examples where knowing what type of impact your paper has is very important for deciding what journal you aim for. So, in the first example about Snowball Earth, it's that you don't want to undervalue work that needs high visibility. So, Paul Hoffman has his science paper, Snowball Earth, and he originally wanted to publish it in a much longer, more detailed format. But his co-author, Dan Schrag said, boo, boo, boo. This needs to be published in a very high visibility journal. It's a very controversial idea. And the only way people will know how controversial it is if it's published in a Nature or a Nature Index journal. So that would not have been published in Science if it were not for Dan Schrag having that instinct. And that instinct was correct because the Snowball Earth hypothesis in the years that followed was very controversial for at least 10 years. And that's a large fact because of they published in the right journal. Didn't undervalue that work. But you also don't want to over publish work that needs credibility. By over publish, I mean try to get a Science or Nature paper and the results actually will be better received if it's in a different type of journal. The example I use here is also involving Paul Hoffman, this time with one of his students. True Polar Wander is a very controversial topic. It's part of my work. And in the years before, there had been two very high profile papers in Science on True Polar Wander. So when Paul Hoffman's student comes along, Adam Aloof, and has very, very convincing evidence of True Polar Wander. He wants to go to a Science or a Nature, and Paul says, boo, boo, boo. We could try, but what this topic, True Polar Wander, really needs at this point, it doesn't need another controversial science paper. It needs a long format paper in overwhelming in the main text that everyone can see. So I went to GSA Bulletin, and this is one of Adam Malouf's best papers. It absolutely had a large impact in the field of making True Polar Wander a very credible mechanism, not only a controversial and exciting one, but very credible. So there's two different ways of having impact here in terms of visibility and credibility, and you need to be honest about what it is. Reading is writing. Reading is writing. Reading is writing. Okay? If you want to know the best way to become a better writer, it's reading. So how do you do that? You don't just read every paper from start to finish in your topic. You focus, find good authors you like, and read all their papers. Every good writer has a voice, and you need to be interested in the topic. So as a university student, I was interested in Snowball Earth. And so I picked a couple Snowball Earth papers to read. And in doing so, I learned that Paul Hoffman was not only a scientist that I liked, but a writer that I liked. So I want to give you an example of why his writing was appealing, and I'll read it. Climate physicists originally assumed that no ice albedo catastrophe ever actually occurred because it would be permanent. The high planetary albedo would be irreversible. A savior exists, however, and Kirschvink identified it as the buildup of the intense atmospheric CO2 greenhouse, yada, yada, yada. A savior exists. This is very exciting for a science paper. He's basically calling uh, atmospheric CO2 emission, volcanic CO2 emissions, a savior, kind of like Jesus Christ or something. So it showed to me that science writing can be interesting without being too flashy. It quite literally is a savior. Earth never would have escaped snowball Earth if it wasn't saved by volcanic emissions. And instead of saying that, he used the word save. So I read all, and I will continue to read all of Paul Hoffman's papers. You need to find your Paul Hoffman and read all of their papers. So when you're reading their papers, you will help writing your papers. Why? Mimic, mimic, mimic. Okay, we are related to great apes. We are great apes, and great apes learn by copying others. Here you see this chimpanzee. He didn't wake up and decide to cross his legs. He is just mimicking, copying what a human is doing sitting next to him. But it's very important to avoid plagiarism. I'll talk about this a little bit more next. But copying in quotes, mimicking is a very important way to become a better writer. And what do I mean by copying? You bring together different phrases from different papers. I would argue that all the building blocks, the terminology, how to talk about the terms, the implications of this type of analysis, the relationships between the different variables in your study, all those building blocks for your writing of your paper are available if you read the most relevant papers. And when you go to write your paper, you can find similar sentences and structure yours around that. Structure your paper the way another paper, a similar paper, is structured. We all do this very much with our methods sections, right? But I would argue that even the results, introduction, the whole paper can be a little more creative, very similar to how you mimic other paper method sections. You can mimic other papers, get ideas for your writing. But mimicking is so important. I really make another point that is very serious. Plagiarism, directly copying someone's work, must be avoided. Okay. And by learning how not to plagiarize, you really learn how to mimic. What is plagiarism? It's hard to define the line between what's plagiarism and what isn't, but you know it when you see it. You cannot just arrange the sentence structure. You cannot just replace words with synonyms, different meaning words. Some combination of changing the sentence structure and replacing words with synonyms is better, but even then, it might still be insufficient. Some change in meaning is really required to make it your own. So I give an example. The original reads, rapid exit from such a climate state would require an extraordinary powerful trigger because a warm ocean atmosphere system has a substantial buffering effect on climate, with a reference. Here's a wrong plagiarism. An extraordinary powerful trigger is required to rapidly escape from such a climate state because of a substantial buffering effect on the climate of a warm atmosphere ocean system. All that was changed was the sentence structure. The first clause and the second clause were switched. Okay. And only one synonym was changed. The rapid exit was changed to rapid escape. All the other words are the same. So I give a version that is okay. It's a combination of different sentence structure and replacing words with synonyms. Because of the appreciable buffering effect that such a one-sphere system has on climate, rapidly transitioning into a snowball would require a uniquely powerful trigger. So we've changed the sentence structure. We've changed substantial to appreciable. We've changed extraordinarily powerful to uniquely powerful. And most importantly, instead of talking about escaping from the warm climate, we changed the meaning of transitioning into a cold snowball climate. But I give this example because this is as close as you would want to get to plagiarism. You don't want to get any closer, and ideally, you would use one concept, use the buffering effect idea, but keep the ideas separate. So just, mimicking is so important, but you can't plagiarize. So learning how not to plagiarize is one of the best ways to learn how to mimic and learn efficiently from others. So if reading is writing, reading is so important, how do we read a scientific paper? I would say never, almost never, read from start to finish. Reading order is critical for efficiency of understanding. I'll talk about this next. Only read more if you want to know more once you go through the order. And depending how much you want or need to know about a paper, you can stop at any time. And again, almost never read a paper from beginning to end. The papers likely were not written that way either. So why would we read them that way? So what do I mean by reading order? Don't read from start to finish. This is again, you may find a different way for yourself, but this is what I typically will read the order of in a paper. And obviously, this order may change based on when you pull up the paper and your eye is drawn to one thing or another. But this order is very efficient. Start with the title. Titles are very important. We'll definitely talk about how to write good titles later. Number 2, look at the pictures. Even before you read, look at the pictures. They're easy to read. And read the caption if you need to understand it or if you're interested. So read the title, look at the pictures. 3, read the last sentences of the abstract and the conclusion. Not the whole abstract, not the whole conclusion. Go to those last 2 sentences of the abstract and maybe the lead sentence of the lead and last sentence of the conclusion. Read the main points before you read all the points. And then after that, read the introduction. This tells you what the authors think their paper is about. And then in order, depending on your goal, read the methods, results of discussion, again, the order that you're interested. Never read a paper from beginning to end. Only if it's a paper of one of the very few papers you want to know everything about. But even that, you've only read a paper from beginning to end after you've read it in this efficient reading order. And this is probably more relevant to professors, young professors, but even graduate students. Once you publish your first paper, that journal you'll be in their database as someone who can actually review papers. And review. Okay, don't be afraid. You can be anonymous. Other native speakers struggle with writing. Even native speakers, other non-native speakers struggle with writing, and even native speakers struggle as well. And reviewing is a responsibility. Li Jiangxiang has a rule: review 1 paper for every 3 papers you submit. There's typically 3 reviewers on your paper. So for every 1 paper you submit, you should review 3. but I should tell Pongasha to not review too many papers. Don't think of reviewing papers as a waste of time. It offers the privilege of advanced knowledge of new work. It provides an inside view into why papers get accepted or rejected. It allows for anonymous practice. Don't be afraid. So more reading. And it earns you the favor of editors. So helping your papers when you submit to these journals. I want to talk a little bit about workflow. What's from the beginning to publication? What's your writing workflow? And ideally, once you're young in your career, you'll be dealing with more than one paper, okay? Especially if you work with colleagues. And I think about writing workflow as juggling, okay? The review process takes a long time, especially at high impact journals. You may be dealing with 1 round, 2 rounds of review. You may be dealing with rejection from one journal, submission to another journal. Review process takes a long time. So really you should have papers at 3 different stages at all times. You should have some paper in preparation, another paper in review, and 1 paper in revision. And for professors, you'll have a couple in preparation, a couple in review, and a couple, maybe 1 or 2 in revision. Only 2 balls, you can see in the picture, only 2 balls or papers, if you're juggling, can be in your hands at any one time. That's the one that you're preparing and the one that you're revising. But you got to throw the balls up in the air, out of your hands, and they're in review. So the idea is to get as many balls in the air, get as many papers in review as you can. If you can only juggle three balls, you can only juggle 3. The better you get, you can add a 4th, add a 5th, add a 6th. It's just like juggling. But it's important to have at least 3 in the process. And why do I mean that? There's a fallacy of one priority. It's okay to have a priority, but more realistically, you probably have several priorities. And why? There's 3 different ways a paper can be a priority. Number 1, revisions should be prioritized. Why? Revisions are the closest to being published. You've put so much work in, why not prioritize it to get it published? Number 2, important science should be prioritized. Your biggest contribution should really be your number 1 priority. If you have time for your revision, why don't you spend some time getting your important paper in review and then go back to your revision if the editor has given you several months, for example. And number 3, obviously, deadline work needs to be prioritized. If you only have 1 month for your revision, then that revision is a big priority. If it's a special volume, if it's a colleague's paper who really wants to submit it, deadlines are another reason. So with 3 different ways for papers to be priorities, that means that you don't really have one priority. And even for PhD students, this goes for you too, because there will always be delays along the way. You're waiting for lab time, you're waiting for reviews, you're waiting for your advisor's comments, you're waiting for edits or data or analysis from co-authors, et cetera, et cetera. You all know these delays. So it's very important to start new projects before other ones finish. And to use the juggling analogy, get another ball in the air. And like anything, accounting, anything important, with your money, it's important to know what money's coming in, what money's going out. how much time you're spending, how much money you're spending on different activities. Accounting for your writing workflow is very important. So I highly recommend to make a paper list, and you color code your paper list by step. Okay, so at the top, you have in blue, you have published papers. That's the end. Okay, in the bottom, or below published, those in red, those are the ones in revision, the closest to being published. And then in orange, we have two types. A paper that's in review, it's a revision, it's a review of a revised manuscript, and then obviously papers that have been submitted for the journal for the first time that are in review. And finally, at the bottom in purple, we have those papers that are in preparation. Okay. Making this list is encouraging to see progress, even if it's just movement from submitted to in review. You know, updating your list will make you feel like you're making progress along the way. Okay, and I like to give my papers pet names, 1 or 2 word names. This helps you and your co-authors refer to our paper more easily, especially if you hopefully have more than one paper in progress with your team, your lab. You can say, oh, how's that paper about Jiaobei doing? How's that paper lead paradox doing? How's the Lucy paper, Chang'er? And so I call them pet names. Kind of another way to make you like your papers as opposed to dreading and not liking your papers. And use your co-authors. When they are working for you, you can work on something else. So you'll notice that in orange, in review, those are the balls out of my hands. They're up in the air. I can't do anything. But in purple and in red, those are the things that I can contribute to now. And the ones that are bold are things that are waiting for me. I need to edit that draft with some specific reminder. Oh, I got the edits from the USGS geologist. And the other ones that are not bold, those are waiting on a co-author to send me a latest draft. Okay, so always know what your, be very scientific about your writing workflow. In the same way that you would be accounting for your data, account for your writing workflow. Keep yourself. Now we're going to start getting into more specific techniques for improving your writing. And if there's one rule that is always in your mind when you're editing a draft, you write your first draft and you may not worry about this. When you reread it, you think about the economy of words. How many words are you using? There's a reason that science only allows for 125 words in the abstract. There's a reason why nature only allows for 200 words in the abstract, why nature geoscience only allows for 180 words in the abstract. PRL, 150 words, okay? Less is more. If you are more confined to a smaller space, the quality has to be better. It's a focus on quality, not quantity. So what does economy of words mean? It means delete every unnecessary word. Every word matters. There's a reason science, nature, geology papers are short. It's not just because there's limited space. It leads to better writing. Sometimes this means reorganizing sentence structure, not just in order to remove words. If you change the structure of the sentence, you can do that. And the example here I give may not seem important, but really every word matters. And I think this example is a little more specific to the actual process. So the top one, the original version, reads, the rock associations are representative of the continuing effects of cratonization after the Neo-Archean and record a tectonic shift from subduction collision to post-collision. Now, I've only deleted one word, but every word matters. And here's how the other version reads. The rock associations are representative of the continuation of cratonization after the Neo-Archean. Its cratonization is a process itself. Okay, so the original version actually talking about continuing effects of cratonization is a little inaccurate. It's actually the continuation of the cratonization process itself. So here, by just focusing on the economy of words, actually made me realize that the meaning is now more precise. So every word matters, and in limiting the number of words, I think you'll find that the meaning of your writing will actually improve as well, and make it more appropriate for short format, high impact journals. Writing is selling. Products do not sell themselves. If you don't sell your idea, people won't buy it. How important is your result? To know how important your result is, you must know the literature. To use an analogy, for an investor to know how successful a product will be, they have to know the market. What are people looking for? What will sell to that customer? What sold last year? Okay. And science writing is the same. If you want to send your paper to Nature Geoscience and they publish a paper on that same topic last year, you not only have to know that paper very well, you have to know whether you have advanced the topic really significantly enough from that last publication to warrant another publication. So you have to find your selling point. You must know top papers on your topic. Editors will want to know what your advance is beyond them. And as we'll talk in cover letters, sometimes you even need to explicitly address, we know you published this paper. Here's how our paper is better. Now, how do you find your selling point? It's not really complicated. In fact, it's the opposite of complicated. Call it what it is. So Andy Knoll, a very successful paleontologist at Harvard, he has this principle that he shared with a co-author of mine. And Andy Knoll calls it the call it what it is principle. And it's how he defines what your contribution is. You know, honesty is the best policy. Don't make some complicated word, some complicated terminology, and a scientific innovation that is exciting is often simple. So I wanted to give a couple examples from my own papers. We had this geology paper, Goldman, astrochronologic correlation of a Mesoproterozoic oceanic euxinic event. We didn't know what to call the event. We know there was oceanic anoxic events, but in the Proterozoic, there wasn't much oxygen. So it didn't really make sense to call it an oxic event. And that was going to be controversial. So eventually, one of my co-authors said, let's just call it what it is. It's an oceanic euxinic event. High sulfide ferruginous ocean. And why was that helpful? Well, we actually ended up coining a new term by just calling it what it is. We weren't trying to be clever. We weren't trying to sound smart English speakers. We were just going back to the basics of our finding. What do our observations indicate? And let's call it what it is. Another example of the call it what it is principle came from Wang Chang's paper on megacontinents. Originally, we were calling these superblocks because we were thinking kind of supercontinent cycle. But then Paul Hoffman helped us realize when he was editing an earlier draft of our manuscript, he pointed out what he called the continental hierarchy. You go from a supercontinent like Pangaea down to a smaller megacontinent like Gondwana, down to a continent of Africa, and down to a microcontinent of Japan. So with continent, continent, continent in the other three terms, that helped us realize for our new term within the continental hierarchy, what it is. All the terms that relate in this case have continent in the term. So even though we were thinking super block in the term that it's a large building block for a supercontinent, by calling it what it is, a mega continent in this continental hierarchy, we actually defined a new term that's both consistent with the existing terminology and a new exciting term that is hopefully useful in tectonics. So don't be too clever, call it what it is. And titles are critical. First impressions matter. Some people just read titles. I hate to say it. I hate to say it. Some people just read titles. They definitely just read titles when they're deciding if they're going to read your paper, if they're going to download your paper. And there's a couple tricks for titles. We'll talk more about this. One trick, not in nature or science science advances, but there's a colon trick, okay? Little two dots. And why do I like the colon trick? Well, you get two titles for the price of one. You can have an exciting teaser in the first part, and in the second part, a more informative portion. So one of the examples, here's my Gulf of Nuna. Gulf of Nuna, a new concept, okay, followed by call it what it is, astrochronological correlation of Mesoproterozoic, blah, 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 blah. But you get two titles for the price of one, where Gulf of Nuna, in 3 words, people can know, ooh, this is an exciting new concept. And there's another trick, again, one that I learned from Paul Hoffman, about a question mark trick. This is another way of getting two titles for the price of one. Controversial ideas are better received if they're asked in the form of a question. So here's my example from my first published paper: oceanic and anoxic cycles, question mark, orbital prelude to the Bonarelli, da, 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 da. So an exciting teaser. People had talked about oceanic events, and we were controversially saying that these events aren't really events, but they're cycles happening in a periodic fashion. So it's incorrect to think of them as unassociated events. But by asking it in the form of a question, it made reviewers a little more easy that we weren't completely convinced of this, but it's exciting enough to get published in a Nature Index journal like EPSL. Titles are really critical, not just for the final version of the paper, but really getting to the final version of the paper. It helps define your idea. It helps with journal selection. If you can think of, is it a nature science title, or like this last two, with the question mark and the colon, more of a geology PSL title? And again, mimic, mimic, mimic. look at many titles of the journal you wish to submit. If I'm thinking of writing a nature paper, I'll open 20 recent nature papers and look at the titles. Look at the structure of the titles, the words of the titles, especially the short, Nature Geoscience, NC, essay, these short titles. Look at the words in the structure. Even use the font, okay, the font size. Sometimes if you use a bigger font size, it may help you think bigger. And mimic, mimic, mimic. You can cobble together one part of one title, another part of another title, replace the terms with your terms, and come up with an original, exciting title for yourself. And geology, you might have noticed this, they love these cliches and idioms. On one hand, that's a disadvantage for many of you that may not know the English American idioms. But if you think of one in Chinese, I would guarantee you that there's a similar idiom or cliche in English. You'll be very surprised how many idioms are shared around the world. So here's just an example. Not all supercontinents are created equal. So, part of the Declaration of Independence in Mexico is that all men are created equal. So here they've used this clever idea that even though there's the supercontinent cycle, one cycle could be different from another cycle. The Rodinia case being a very unique supercontinent cycle for reasons that we're trying to figure out. So, you can have a little fun with the titles. So that's the end of today. We do have, I left at least about 9 minutes for questions. If you want to ask a question now, feel free to ask now. If you want to email me, feel free to email me. But thank you for listening.